next we're going to generate figure 4.1, and here we are looking at the different values of a given variable. What percentage of it is okay, so we are plotting this against cat-med-v being our target. Okay, so what within each value of zn, what is the proportion of cat-med-v equal to 0? What is the proportion cat-med-v equal to 1? So 0 to 100%. So for each value of zn, what is the distribution between 0 and 1 for cat-med-v? That's what this graph tells you. So if you have similar distributions between the cat-med-v and zn, say for example here 28 and whatever this value is 29, I suppose, they both have all zn cat-med-v equal to 1, I guess. So these two can be combined, and here these three can be combined because they are all the same. So this way you're reducing the number of levels for zn, and that reduces the dimensionality. So a graph like this would be useful, but actually just looking at this plot is I mean, more value can be added by looking at how many observations are there in each of these zn values. Okay, if there are only one or two observations, then that also can be combined, even if they are not similar. So, for example, that one and that one. Okay, so well, these two, they are not exactly same, but if there are only few observations, these two can be combined. So that's the idea. So we're going to use a table function, okay, first between cat-med-v, and so we do table Boston df, right? And then we specify between what two variables you want the table. So you want table between cat-med-v, comma, Boston housing zn. Okay. So now if you run that, so you get 0 or 1 for cat-med-v, and then you have all the zn values. Now remember, the table function will generate a table object. Okay, so you want that table object to be converted into data frame. So let's call this table tbl.df, and we'll take the table and put data frame around it. So the table result will then be converted into a data frame and saved in this object. So now we have an object here. So we have var1, that is our cat-med-v, var2 is zn, and then the frequency. So we can give names to this table. So we say names tbl.df, okay, and we'll give names. First one is cat-med-v, right? The second one is zn, and the third one is frequency. So let's call it frequency. Okay. So once that is done, then we can plot that. So we have zn, cat-med-v, and the frequency, right? How many are there for each combination? So we can do a ggplot, data equal to tbldf, mapping AES x equal to Zn, right? y equal to frequency. So you want to plot the frequency. Right, and what we want to fill. Okay, we want to fill the bars. Okay, so that's what was going to make it into a stacked bar. So if you say fill equal to cat dot med v, so each frequency will be separated by how many zeros and how many ones. So for example, here for cat med v 0 and zn 0, the 339. So zn 0 cat med v equal to 1 is 33. So these two will be stacked one on top of the other because we are saying fill equal to cat med v. So cat med v has within each zn, cat med v will be used for the bars. So then we need to say how you want to plot this. So geom bar, we want stat equal to identity. Okay, then run that. Okay, so that will give you a stacked bar. But this is not a percentage stacked bar, so which is called the distribution chart. So here, instead of going from 0 to 100%, it's actually plotting the frequencies. So that's why the height of the bars are not all the same. So we have to add here position equal to fill. Okay, so now if you run, so that's going to change it to 0 to 100%, and you'll get the chart. And then you can add a title, GG title, distribution of cat med v for Zn.